Greetings, ladies and gentlemen. In this video, we are going to start solving this past paper, which is science paper 1. By the way, science paper 1 is physics. Okay, and the year when this paper was written is 2020. Exam is just around the corner. Okay, without wasting much of our time, let us begin. Question A1. How many significant figures are in 2.0800? So to know the number of significant figures, the first thing that we are going to do, we are going to come up with the 5 rules that we need to consider when counting the number of significant figures. So number 1, we need to remember that non-zero digits are always significant figures. Okay. For example, 245 has 3 significant figures. So non-zero digits are always significant figures. So we have seen that all these are significant figures. Rule number 2, any zeros between non-zero digits are significant figures. For example, we have 2035 here. So 2035 has 4 significant figures. Why are we saying so? We can see that this 0 is between 2 and 3. Okay, this 0 is between 2 and 3. So therefore, this one is considered to be one of the significant figures. Rule number 3, leading zeros before 0 digits are not significant figures. So we have seen that the leading zeros are not significant figures, are not considered to be significant figures. So we can see that this number has 3 significant figures. Rule number 4, trading zeros at the end are significant figures only if there is a decimal point. So for example, 100 has 1 significant figure. Reason being, there is no decimal point at the end of this 100. But we can see that here we have 100.0. So 100.0 has 4 significant figures. Reason being, there is a decimal point here. So since there is a decimal point here, these are trading zeros. So therefore, these trading zeros are considered to be significant figures. This number has 4 significant figures. Rule number 5, in scientific notation, all digits in the coefficient are significant figures. In scientific notation, all digits in the coefficient are significant figures. So we have the coefficient which is here. So we can see that this coefficient has 4 significant figures. So all digits in the coefficient are significant figures. So we can see that here we have excluded the leading zeros, 3 leading zeros. We have excluded 3 leading zeros. And we can see that this one has 4 significant figures. Now let us come back to our question. So we can see that this 0, the 0 which is here, is between 2 non-zero digits. So therefore, this one is considered to be a significant figure. And we have 2 zeros at the end. So these 2 zeros at the end are considered to be significant figures because these are trading zeros. So therefore, we can see that this number has 5 significant figures. Our correct answer is D. Okay. We shift to the next question, which is question A2. Question A2 reads, which of the following contains base quantities only? Which of the following contains base quantities only? A, length in kilometers, mass in tons. B, length in meters, mass in tons. C, length in kilometers, mass in kilograms. D, length in meters, mass in kilograms. So, ladies and gentlemen, we'll do well by first defining base quantities. What are base quantities? Let us differentiate. Let us give the difference between base quantities and uh, base quantities and the derived quantities. So the base quantities, a base quantity is a fundamental physical measurement that does not depend on the quantities. Okay, that does not depend on other quantities. So in a simple language, we are simply saying base quantity is a foundation quantity. Okay, is a foundation quantity. So for this reason, it doesn't depend on other quantities. Let us also define the derived quantities. So what are derived quantities? Derived quantities are physical quantities that are calculated or derived from the combination of fundamental quantities, also called the base quantities, through mathematical operations. So derived quantities are extracted from the fundamental quantities or the base quantities. Okay. And normally the base quantities have only one unit. The derived quantities normally have two or more quantities. Okay, two or more quantities. Now they want us to give the list with the only base quantities. So here we have the list of base quantities. We have length, we have mass, we have time, we have temperature, we have electrical current. And we can see that they only have one unit, one unit, one unit. Okay, so therefore our correct answer here is uh, D. Length is measured in meters and mass is measured in kilograms. So what is wrong with the A? A, length measured in length in kilometers. No, length is not measured in kilometers according to the information given here. So we have seen that length is measured in meters, mass is measured in uh, kilograms, not in tons. What is wrong with B? Length in meters, mass in tons. Okay, white or light here, it is okay. Length is measured in meters, but mass is not measured in tons. What is wrong with the C? Length measured in kilometers. No, length is not measured in kilometers. Length is measured in meters according to the information given here. Okay, so therefore, our correct answer is D. Without wasting much of our time, let us move to the next question. We move to the next question, which is question A3. Question A3, the following diagrams show steps that Elena carried out in order to determine the volume of a wooden cork. Which one is the volume of the wooden cork? Which one is the volume of the wooden cork? Okay, so this method is called displacement of water. So displacement of water is used to find the volume of the irregular solid. Okay, irregular solid. So what you would do here, we are going to identify volume 1 and volume 2. Then to find the volume of the wooden cork, we are going to say the volume of the wooden cork is equal to volume 2 minus volume 1. So what are we going to do to find volume 2 or to find volume 1? So the first thing that we are going to do is to identify the volume of the liquid. So the volume of the liquid according to the beaker or according to the test tube given here. Okay, according to the beaker given here, the volume of the liquid is 50 cubic centimeters. Okay, 50 cubic centimeters. We can see 40, we can see 60. So between 40 and 60, we have 50. So the volume of the liquid is 50 cubic centimeters. The volume of the liquid is 50 cubic centimeters. After immersing the bulb, the liquid rose from 50 to 60. So therefore, we can easily say the volume of the bulb is 10 cubic 10 cubic centimeters. The volume of the bulb is 10 cubic centimeters as indicated. Okay. So the volume of two bulbs, we have two bulbs in the here in step 3, we have two bulbs. So the volume of these two is, we are going to multiply by 2. We are going to say 10 cubic centimeters times 2. 10 cubic centimeters times 2. Then we are going to get 20. So therefore the volume of two identical bulbs, the volume of two identical, okay, the volume of two identical bulbs is 20 cubic centimeters. 20 cubic centimeters. Then we are going to say, let us come up with data. We come up with the data. Okay. So we are going to say the volume 1, we are going to say volume 1 is equal to 50, the volume of the liquid, plus 20, the volume of two identical glass bulbs. Okay. We are going to get the volume of the liquid is 50. The volume of two identical glass bulbs is 20. 50 plus 20, we are going to get 70 cubic centimeters. So this is our volume 1. Okay. After immersing the wooden cork, the volume rose again from 60 to 100. So 100 is our volume 2. 100 is our volume 2. So therefore, to find the volume of this wooden cork between these two identical glass bulbs, we are going to say volume of the wooden cork is equal to volume 2 minus volume 1. So 100 is our volume 1 minus 70. 70 is our volume 100 is our volume 2. 70 is our volume 1. Then we are going to say 100 minus 70. We are going to get 30 cubic centimeters. So therefore, our correct answer here is A. Our correct answer is A. Without wasting much of our time, let us move to the next question. We move to the next question, which is question A4. Which of the following diagrams show accelerating car? Which of the following diagrams show accelerating car? So before we answer this question, we need to understand this. Shape of the graph. Let us discuss the shape of the graph. The graph will start as a straight line if the car was initially moving at constant speed or stationary, or if the car was stationary. But will begin to curve upward more steeply as the car's speed increases or accelerating. Okay, so the car will start with the graph will start as a straight line. Then as it's progressing, it will tilt towards the speed or towards velocity. So this shows that the car is increasing the speed within the shortest period of time. Okay, so we can see this is the graph we are talking about here. So this graph is curving towards the velocity or the speed. Is curving toward the velocity or the speed. So this graph is showing accelerating car, or it is showing an object with increasing velocity. So therefore, the graph that is representing accelerating car here is B. We are done with this question. Let us move to the next question. We move to the next question, which is question A5. Question A5. The diagram below shows a light bar PR pivoted at P, balanced by 4 Newton weight and force F. What is the reading on the Newton balance? Okay, so we need to remember that sum of clockwise moments is equal to sum of counterclockwise or anticlockwise moments. So which one is our clockwise moment? So this is our clockwise moment. So we have force, which is the 4 Newton, and we have the distance, which is 30 centimeters. And which one is our counter clockwise or anticlockwise? So anticlockwise is this one, the force, the upward force. The upward force is our counterclockwise. Then the distance is, this is our distance. Okay, this is our distance. Now let us come up with the formula that will help us uh, to find the force. So we are going to say force 1 times distance 1 is equal to force 2 times distance 2. Do we have force 1? Yes, we have force 1, which is 4 Newton. So force 1 is 4 Newton. Then distance 1 is 30 centimeters. Okay, so here let me clarify something here. When you are calculating the moment of forces, you need to convert distance to meters, from centimeters to meters. But here we are calculating force. We are calculating force. So even if we convert centimeters to meters, we'll still get the same answer. So here we are not going to stress ourselves by converting centimeters to meters. So the centimeters will cancel. Okay, the centimeters will cancel. In short, centimeters have no effect or no impact on our calculations. They won't affect our final answer. So this is the reason why we have not converted centimeters to meters. Okay, just in case you are wondering, you can only do that if you are taught to calculate the the moment the moment of forces. Okay, so we are going to say 4 times 30, we are going to get 120. Here we have 50. So to calculate F2, we are going to divide both sides of the equation by 50. Here divide by 50, even here divide by 50. Then uh, we are going to say 120 divided by 50. We are going to get 2.4 newtons. So 2.4 newtons is our final answer. So therefore, our correct answer here is B. Our correct answer is B. We are done with this question. Let us move to the next question. We move to the next question, which is question A6. Question A6. A car is traveling on a level road. Suddenly, the driver of the car sees a cow crossing the road and decides to apply brakes. What are the energy changes as the car slows down? A. Chemical to kinetic and sound. B. Heat to kinetic and sound. C. Kinetic to chemical and sound. D. Kinetic to heat and sound. Okay, so to answer this question, let us discuss something here. The lost kinetic energy is converted to heat, sound, and deformation energy. Deformation energy due to friction between the brakes and the wheels. So here, guys, we need to apply the conservation of energy. So conservation of energy states that energy cannot be destroyed, but it can be converted from this form to another form. So we have seen that the kinetic energy has been converted. The kinetic energy has been converted to heat, sound, and deformation energy due to friction between the brakes and the wheels. Okay, due to friction and the wheels. So the energy has been converted to heat, sound, and deformation energy. So therefore, our correct answer here is kinetic energy and sound energy. We shift to the next question, which is question A7. Question A7, the graph below shows a cooling curve of a gaseous substance. In which state or states of matter will the substance be between point F and G? Okay, A, gas only, B, liquid only, C, gas and liquid. D, solid and liquid. Solid and liquid. So to answer this question, let us compare these two curves. So the first one, we have the heating curve. Okay, we have the heating curve. The second one, we have the cooling curve. So our major interest is here, the cooling curve. The cooling curve. So between gas and liquid, the state of the substance given will be in liquid and gas. Will be in liquid and gas. Okay, will be in liquid and gas. So therefore, our answer is gas and liquid. Gas and liquid. We move to the next question, which is question A8. Question A8. The following diagram shows a water wave. The following diagram shows a water wave. Which row gives the correct values for the wave amplitude and wavelength? Okay, and wavelength. So to understand this question fully, we need to remember that amplitude is the distance between this principal and the crest or trophy. The distance between the principal and the trophy, or amplitude is the height of the wave starting from this line. Then wavelength is the distance between two successive crests or two successive trophies. Or we can say wavelength is the distance covered by a complete wave. Wavelength is the distance covered by a complete wave. So we can see that here we have this distance, and this distance is 80 centimeters. But we have seen that our amplitude here is not exceeding this line. Our amplitude is not exceeding this line. So therefore, we are going to find the half of 8. The half of 8 is 4. Then here, to come up with a complete wave, so this is a semicircle. So the length of this semicircle is 5 centimeters. So to come up with a complete wave, we need another semicircle. Then we are going to say 5 times 2 is equal to 10. 5 times 2 is equal to 10. So 5 times 2 is equal to 5 times 2 is equal to 10. Our wavelength is 10 centimeters. So therefore, our correct answer here, our correct answer is A. Our correct answer is A. Two semicircles make one complete wave, or 4 quarters make one complete wave. We are done with this question. Let us move to the next question, which is question A9. Question A9, the diagram below shows a learner in front of a sound speaker that produces sound. Which of the following diagrams best shows how the gaseous air molecules between the learner and the loudspeaker will move? So the first thing that we need to do is to understand the type of wave being discussed here. So the type of wave being discussed here, the sound wave. Sound wave is a longitudinal wave. Okay, sound wave is a longitudinal wave, and the particles of sound wave propagate or move parallel to the direction of the waves. Okay, then the particles of transverse wave move perpendicular to the direction of the wave. So since we are talking about longitudinal, we are going to say in longitudinal wave, the particles of the medium move parallel to or from the direction of the wave. Okay. This means that the motion of the particles is along the same line as the wave travels. So we have longitudinal here. We can see that the particles of longitudinal wave are propagating uh, parallel, propagating parallel to or from the direction of the wave. So therefore, the one that is showing parallel propagation here is A. So A is showing parallel propagation or parallel movement of the particles. We are done with this question. Let us move to the next question. We move to the next question, which is the question A10. Question A10 reads, a girl height 1.2 meters stands 4.0 meters in front of a plane mirror as shown in the following diagram. How far is the girl away from her image? Okay, so to answer this question fully, to understand this question fully, the first thing that we need to understand that the distance between the object and the mirror is equal to distance between the mirror and the image. Okay, so we have seen that the distance between the mirror and this girl here is 4 meters. So therefore, the distance between the mirror and the image of the girl is also 4 centimeters. So to find this distance, the distance between this girl and her image is 80 centimeters. How have we come up with 8 centimeters? So we have simply said 4 plus 4 is equal to 8. So therefore, this distance is 8.0 centimeters. The distance between this girl and her image is 80 centimeters. Is 8 centimeters. We are done with this question. Let us move to the next question. We move to the next question, which is the question A11. Question A11. A line JK drawn on a piece of plain paper on which a glass uh, on which a glass block is placed was viewed through the top, and its image was located using a pin as shown in the following diagram. If KL is equal to 1.8 centimeters and KM is equal to 4.8 centimeters, what is the refractive index of the glass? What is the refractive index of the glass? So to find the refractive index of the glass, the first thing that we are going to do is to identify the real depth and the apparent depth. So we are told that the real depth is 4.80 centimeters, and the distance between K and L, the distance between K and L is 1.80 centimeters. Let us find the apparent depth. So this is the apparent depth. So to find the apparent depth, we are going to subtract 1.8 from 4.8. Okay, from 4.8, then we are going to come up with the apparent depth. We are going to come up with apparent depth. Let us come up with the data. Let us correct data. So the real depth is 4.8 centimeters. The apparent depth is 4.8 centimeters minus 1.8 centimeters. So therefore, okay, the apparent depth is equal to 3 centimeters. Now let us write down the formula. We are going to say the refractive index is equal to real depth divided by apparent depth. Okay, the real depth is 4.8 centimeters divided by 3.0 centimeters. 4.8 centimeters divided by 3.0 centimeters. We are going to get 1.6 centimeters. Okay, we are going to get 1.6 centimeters. So therefore, our correct answer here is C. Our correct answer is C. We are done with this question. Let us move to the next question. We move to the next question, which is question A12. Question A12, which of the following materials would be most suitable for constructing the core of the electromagnet? A. Carbon, B. Copper, C. Iron, D. Steel. Okay, so the best material that can be used to construct the core of an electromagnet is iron. Iron is the best uh, material that can be used. Iron is the best material that can be used. We move to the next question, which is question A13. Question A13, two uncharged metal spheres, Q and P, are placed on insulating stands and separated while the negatively charged polythene stripe is held near Q, as shown in the diagram. As shown in the diagram. We are given the diagram here. The question continues. What would be the charges on Q and P? What would be the charges on P and Q? So to answer this question, we need to remember that opposite charges attract. When two objects have opposite charges, one positive and one negative, they attract each other. Okay. Like charges repel. When two objects have like charges, both positive and both negative, they repel each other. So we have seen that uh, like poles repel, opposite poles attract. Opposite poles attract. So if sphere P is touching Q, the excess negative charges in Q may move to P, making P negatively charged. If the sphere P is not touching Q, it may still experience attraction due to electrostatic forces. Okay, due to electrostatic forces. So, therefore, Q will have positive charges, then P will have negative charges. Reason being, the negative charges in this sphere will push the negative charges in these two spheres to this side. Then we attract the positive charges from these two spheres to this sphere, which is sphere Q. So at the end of this experiment, sphere Q will have positively charged, will have positive charges. Then sphere P will have negative charges. Okay, will have negative charges. So therefore, our correct answer is the B. Q will have positive charges, then P negative charges. We are done with this question. Let us move to the next question. We move to the next question, which is question A14. Question A14, the following diagram shows a network of three resistors, resistor 1, resistor 2, and resistor 3, connected to a battery voltmeters. V1, V2, and V3 are connected to R1, R2, and R3, respectively. The question continues, which of the following expressions show the potential difference, PD, supplied by the battery? So potential difference, we are simply talking about voltage. So potential difference is voltage. Okay. So guys, before we answer this question, we need to remember that in series circuit, voltage is divided among the components. The total voltage is the sum of the individual voltages. While in parallel circuit, voltage is the same across all branches. So voltage across the voltage in parallel circuit is the same across all branches. So here we have components arranged in a parallel circuit. So therefore the voltage is the same here, is the same across the components. So the voltage which is here is equal to this one. So this one and this one are in series, but this one and this one are in parallel. So therefore, here we have the same voltage. So here we have V2 and V3. So between V2 and V3, we are just going to pick one. This one being voltage is the same across all branches. Then for this one, so therefore our potential difference will be 1 plus 3, not 2 plus 3. Here we have the same voltage. Here we have the same voltage. So therefore our correct answer is our correct answer is A. Our correct answer is A. We are done with this question. Let us move to the next question. We move to the next question, which is question A15. Question A15, an electric kettle is rated 230 volts, 3000 watts. What is the suitable fuse to use on this kettle? What is the suitable fuse to use on this kettle? So to find the suitable fuse, the first thing that we are going to do is to calculate electric current. So what are we going to do to calculate the electric current? Let us come up with the data. What have we been given according to our question? So according to our question, voltage has been given. Voltage has been given, which is 230 volts. What else have been given? Potential. Power has been given, which is uh, 3000 watts. 3000 watts. What else? Current. Current is what we are looking for. So therefore, we are going to say power is equal to current times voltage. Okay. Power we have 3000. Power we have 3000. Then current voltage we have 230. So we are going to say 230 times 230 times I. Okay, we divide both sides of the equation by 230. We are going to get 13.04 amperes. Okay, so this is our current. So to find the fuse or to suggest the fuse, so the fuse should be slightly, the current of the fuse that we want to use should be slightly higher than the calculated electric current. Here we have 13. Here we have 13. So therefore the fuse should be slightly higher than this one. Okay. To ensure safety, we typically choose a fuse rating slightly higher than the calculated current. So therefore our answer here, our correct answer is D, which is 15. Our correct answer is D, which is 15. We move to the next question, which is question A, question A16. Question A16, below are 3 statements on electromagnets. Number 1, an electromagnet consists of a coil of wire wound on a soft iron core. B, the strength of the magnetic field produced by an electromagnet increases if the strength of the magnet and or number of the turns of wire is increased. 3. In the diagram below, when the switch is closed, the gap R increases. So let us see. The question continues. Which of the above statements are true? Which of the above statements are true? Let us start with A. An electromagnet consists of coil of wire wound on a soft iron core. So this is true. B. The strength of the magnet field. The strength of the magnetic fields produced by an electromagnet increases if the strength of the current or number of coils is increased. Okay, so this is also true. So current and number of turns are direct proportional to magnetic fields. So once we increase these two, even the strength of the magnetic field will be increased. Let us also consider 3. In the diagram below, when the switch is closed, the gap R increases. Okay, so Let us use right hand rule for electromagnets. Curl the finger of your right hand in the direction of the current flowing through the coil. Conventional current from the positive to negative charge. Your thumb point towards the north pole of the magnet. So if we curl our right hands in this direction, our thumb will point here. The thumb will point here. So where the thumb will point, that is where north is. So we can see that here we have south, here we have north. And we need to remember that opposite poles attract. Opposite poles attract. Then like poles repel. So this gap would decrease. The reason being this magnet will be attracted to this one and this one will be attracted to this one. So gap R will be reduced, not increased. So therefore our answer here is A, not D. I made the mistake here. Our correct answer should be A. 1 and 2 are correct true statements. We are done with this question. Let us move to the next question, which is question A17. Question A17, the diagram below shows a filament lamp rated 6.0 volts connected to the output of a transformer. What happens to the lamp when the circuit is switched on? What happens to the lamp when the circuit is switched on? So the first thing that we are going to do is to find the voltage. So the transformer that has been given is a step down transformer. Okay. So let us define a step down transformer. A step down transformer is an electric device used to reduce the voltage from higher value to a lower value while maintaining the same frequency. Its primary function is to convert high voltage into lower voltage for use in applications where high voltage is not necessary or is unsafe. So let us find the voltage. So to find the voltage, we come up with the data. What have we been given? The number of turns in the primary coil has been given, which is 300 turns. The number of turns in the secondary has been given, which is 20 turns. The voltage in the primary has been given, which is 240. The voltage in the secondary is what we are looking for. Now let us write down the formula. So we are going to say voltage in the primary divided by voltage in the secondary is equal to number of turns in the primary divided by number of turns in the secondary. Number of turns in the primary is 240. Voltage in the primary is 240 volts. Then voltage in the secondary is what we are looking for. Number of turns in the primary is 300. Number of turns in the secondary is 20. Okay, we do a cross multiplication. 300 times VAC, we are going to get 300 VS. Then 240 times 20, we are going to get 4,800. Here divide by 300, even here divide by 300. Then we are going to get VS is equal to 16 volts. So, and we are told that this one is rated 6. So we have seen that this is way too big. So this is way too big. The voltage is way bigger than the rated voltage, which is 6 volts. So therefore, the filament lamp will light up brightly and then blows off, because the voltage is way too big. We are done with this question. Let us move to the next question. We move to the next question, which is question A18. Question A18, which component used is Which component used in electric circuit allows current to flow through one direction only? A. Diode. B. Resistor. C. Thermistor. D. Transformer. Okay, so the component that allows current to flow in one direction is called diode. Diode. Okay, so therefore our correct answer here is our correct answer is A. We are done with this question. Let us shift to the next question. We shift to the next question, which is question A19. Question A19, an atom of uranium 235 has 92 electrons. How many protons are there in one atom of uranium 235? So to answer this question, we need to remember that in a neutral atom, the number of protons, positively charged particles in the nucleus, is equal to the number of electrons, the negatively charged particles surrounding the nucleus. Okay, so we need to remember that in the neutral atom, the number of protons is equal to number of electrons. So since uranium is neutral, the number of electrons is equal to number of protons. The number of electrons is equal to number of protons. So therefore, since we have 92 electrons here, we also have 92 protons. So therefore, our correct answer is A. We are done with this question. Let us move to the next question. We move to the next question, which is question A20. Question A20, a radioactive material gives a count rate of 80,000 counts per minute. After 20 days, it gives count rate of 500 counts per minute. What is the half-life of the material? A, 4 days, B, 5 days, C, 20 days, D, 50 days. So they want us to find the half-life. So half-life, it is the time it is taken to reduce by half. So for example, the time it is taken for this mass to reduce by half is um, one as shown here. Cos 60 decay. Cos 60 decay. Of course, there is a good number of formulae that we can use to find the half-life. So let us use the simplest one. So this is the formula that we are going to use. Remember, there is a lesson on how to calculate half-life. Okay, there is a video on how to calculate half-life. Actually, I even posted this video. Okay, so we are going to say the original mass is 80,000. The original mass is 80,000. So after one half-life, this original mass will be reduced by half. Will be reduced to 400. After another half-life, this one will be reduced to 2,000. After another half-life, this one will be reduced to 1,000. After another half-life, this one will be reduced to 500. Okay, and we are told that the time it is taken for this 8,000 to be reduced to 800 to 500 is 20 days. So we have how many half-lives? We have 1, 2, 3, 4. So we have 4 half-lives. So therefore we are going to say 20 divided by 4 is equal to 5 days. So the half-life is 5 days. The half-life is 5 days. Let us move to the next section. We move to the next section, which is section B. Section B is carrying 45 marks. Answer all questions in this section. Write your answers in the spaces provided on the question paper. Question B1, figure B1.1 below shows a simple pendulum suspended from a fixed point. The question continues. The bulb is slightly pulled to position A and then reduced. Question A, state one factor that does not affect the period of the pendulum. State one factor that does not affect the period of the pendulum. Here we have factors that affect the period of the pendulum. Number one factor, the length of the pendulum. Does the length of the pendulum affect the period of the pendulum? Acceleration due to gravity affects the period of the pendulum. Now the question is saying the factors that does not affect the period of the pendulum. So the number one factor that does not affect the period of the pendulum is amplitude. Amplitude doesn't affect the period of the pendulum. Number two factor, mass of the pendulum bob. So the mass of the pendulum bob doesn't affect the period of the pendulum. Number three, air resistance. Air resistance doesn't affect the mass of the pendulum. So therefore, from these three, we are going to pick one, which is mass. Mass of the pendulum doesn't affect the period of the pendulum. Just a minute. We move to the next question, which is question B. Question B, if the values of time for 20 oscillations obtained were 16.1 seconds, 15.9 seconds, 16.0 seconds, 16.2 seconds, and 15.8 seconds, calculate the period of the pendulum. The question is carrying 3 marks. So therefore, we need to provide calculations, that is, calculations that are equivalent to the given mark at the end of the question. Okay, so the first thing that we are going to do is to write down the formula. We are going to say the period of the pendulum is equal to, the period of the pendulum is equal to time divided by number of swings or number of oscillations. Number of swings or number of oscillations. Okay, so data collection. So to come up with time, as we can see, we have been given a bunch of times here. Now we need to come up with one time. Okay, so we are going to find the average of the times given here. So we are going to say 16.1 plus 15.9 plus 16.0 plus 16.2 plus 15.8 divided by 5. So 16.1 plus 15.9 plus 16.0 plus 16.2 plus 15.8, we are going to get 80. Divide by 5. 80 divided by 5, we are going to get 16 seconds. We are going to get 16 seconds. Okay. The number of oscillation. The number of oscillation. Have we been given the number of oscillation? Yes. The number of oscillation has been given, which is 20 seconds. So as we can see, we have successfully managed to identify values or to identify data or to collect data. So where there is time, we are going to write it. Where there is time, okay, let us write data here so that we can simplify our work. So time is 16 seconds, number of oscillation is 20 seconds. So where there is time, we are going to write as 16. Where there is number of swings or number of oscillation, we are going to write 20. Then we are going to say 16 divided by 20, we are going to get 0.80 seconds. 0.8 seconds is our final answer. 0.8 seconds is our final answer. We are done with this question. We have successfully managed to calculate the period of the pendulum. Now let us move to the next question. We move to the next question, which is the last part of the first question, which is question C. Calculate the frequency of the pendulum. Calculate the frequency of the pendulum. So to find the frequency of the pendulum, we are going to say frequency of the pendulum is equal to 1 divided by period. Frequency of the pendulum is equal to 1 divided by period. Data collection. Data collection. What have we been given according to our question? What have we been given according to our question? Frequency is what we are looking for. Frequency is what we are looking for. Then period, we have long find in period, which is 0.80 seconds. Now it is the matter of plugging in the value or the data we have collected. So we are going to say frequency is equal to 1 divided by 0.8. 1 divided by 0.8, we are going to get 1.25 Hz. We are going to get 1.25 Hz. Then this is our frequency. So therefore our frequency is 1.25 Hz. 1.25 Hz. We are done and dusted with this question. Let us move to the next question. We move to the next question, which is question B2. Question B2, a car has a mass of 900 kg. It accelerates from rest at a rate of 1.2 meters per second squared. Calculate Roman numeral 1 time taken to reach a velocity of 30 meters per second. Okay, 30 meters per seconds. So to answer this question, the first thing that we are going to do is to group data. Okay, is to collect data, so to say, to collect data. So we need to collect data. So this the we are going to say acceleration is equal to final velocity minus initial velocity divided by time. Data collection. What have we been given according to our question? What have we been given according to our question? So the mass has been given, which is 900 kg. Sorry, I made the mistake here, not grams but kg. Initial velocity is 0. Remember, we are told that this car is starting moving from rest. So therefore, the initial velocity is 0. What else have we been given? The final velocity. The final velocity is 30 meters per second. 30 meters per second. The acceleration has been given, which is 1.2 meters per second squared. Per second squared. The acceleration has been given. What are we looking for? We are looking for time. So let us plug in the values. Where there is acceleration, we have written 1.2. Where there is final velocity, 30 meters per second. Where there is initial velocity, 0 meters per second. Where there is time, time is what we are looking for. We do a we evaluate. We are going to come up with 1.2 is equal to 30 divided by 1. We do a cross multiplication, we are going to get 1.2 is equal to 30, here divided by 1.2, even here divided by 1.2. Then we are going to get time, which is 25 seconds. So therefore, our answer here is 25 seconds. Okay. So the time it took for this automobile to reach the velocity of 30 meters per second is 25 seconds. We are done with this question. Let us move to the next question. We move to question Roman numeral 2. Calculate the force required to accelerate the car at a rate of 1.2 meters per second squared. Now here we are taught to calculate the force. So to find force, this is what we are going to do. So we are going to say force is equal to mass times the acceleration. Force is equal to mass times the acceleration. Let us come up with the data. We come up with data. What have we been given according to our question? So according to our question, we have been given mass, which is 900 kg. What else have we been given? We have been given acceleration, which is 1.2 meters per second. 1.2 meters per second. Have we been given force? Force is what we are looking for. So we are going to say force is equal to 900 times 1.2. 900 times 1.2. We are going to get 1080 newtons. 1080 newtons is the force required to accelerate the car at a rate of 1.2 meters per second squared. We are done with this question. Let us move to the next question. We move to the next question, which is question B3. Question B3, B3.1 below is a diagram showing a load being moved using a wheelbarrow. The total mass of the wheelbarrow and the load is 80 kg. Take gravitational field strength to be 10 meters per kg or gravitational acceleration to be 10 meters per kg. A. Calculate weight of the wheelbarrow and the load. So the weight of the wheelbarrow and the load. So the first thing that we are going to do is to come up with data. What have we been given according to our question? So according to our question, we are given mass, which is 80 kg. So 80 kg is the mass of the wheelbarrow and the load. Gravitational field strength is 10 Newton per kg. 10 Newton per kg. Now let us find, we find weight. Weight is equal to mass times the gravitational acceleration. So the mass is 8 and the gravitational acceleration is 10. So therefore weight is equal to 80 newtons. So this is our final answer. We are done with this question. Let us shift to the next question. We shift to the next question, which is question A, Roman numeral 1. Calculate the force F required to lift the wheelbarrow. The force required to lift the wheelbarrow. So to answer this question, we are also going to apply this principle. The sum of clockwise moments is equal to sum of counterclockwise moments. F1 times distance 1 is equal to F2 times distance 2. So which one is our clockwise moment? This one, which one is our clockwise moment? Okay, so 800 times 0.5 is equal to F2 times. So this is our clockwise moment. 800. 800 is the mass we are from calculating. Is the weight we are from calculating times 0.5. So 0.5 is the distance between the pivot and the center of gravity. So the center of gravity, that is where the 80 kg mass is pointing or centering. So this is where the 80 kg is centering. Then the anticlockwise moment or counterclockwise moment is this force, the distance between the pivot, this pivot, and the handle. So the distance between this pivot and the handle, we are going to say 0.5 meters plus 1.5 meters. We are going to get 2 meters. So the distance between the pivot and the handle is 2 meters. 800 times 0.5, we are going to get 400. F times 2. F times 2. So here divide by 2, even here divide by 2. F2 therefore is equal to 200 newtons. So F therefore is equal to 200 newtons. We are done with this question. Let us move to the next question. We move to the next question, which is question B. States whether force F would increase or reduce when the handles of the wheelbarrow are made longer. Okay, so we need to remember that when we increase the handles, the force will be reduced. So the length of the handles are inversely proportional to force. We increase the length of the handles, the force reduces. We increase the handles of the force, we increase the handles, the force reduces. So we are going to say the force would reduce. We are done with this question. Let us move to question B4. Question B4, figure B4.1 below is a diagram showing a stone of mass 2 kg that was pushed up a slope from Q to R. The question continues, 72 joules of work was done in moving the stone up the slope from Q to R. Question A, what is the potential energy of the stone at R? What is the potential energy of the stone at R? Okay, so here we are going to apply the conservation of energy. So we are going to say conservation of energy states that energy can neither be destroyed nor created, but it can be changed from one form to another. Okay, so we have applied the conservation of energy. So therefore, the potential, remember, work is measured in joules. Energy is also measured in joules. So since we have 72 joules here, so this 72 joules is the potential energy. So therefore, the potential energy we are talking about here is 72 joules. So our answer is 72 joules. We move to the next question, which is question B. Question B, if the stone falls through side RT, what would its potential energy be at S? The midpoint of its 4. The midpoint of its 4. So guys, we need to remember that as this stone is falling from this position here, it keep on reducing, it keep on losing potential energy and keep on gaining kinetic energy slowly but sure. Okay, so now they want us to find the potential energy when this stone is at this position, the midpoint. So to find potential energy, we are just going to find the half of 72. So the half of 72 is 36 joules. So therefore, the potential energy is 36. The potential energy is 36. We are done with this question. Let us move to question C. Calculate height TR. Calculate height TR. So they want us to find this height. So to find this height, we are going to apply potential energy formula. We are going to apply potential energy formula. So we are going to say potential energy is equal to mass times gravitational acceleration times height. Data collection. Let us come up with data. What have we been given? So potential energy, we are from saying potential energy is 72. Mass is 2 kg. Gravitational field strength is 10 Newton per kg. Then height is what we are looking for. So 2 times 20, 2 times 10 is equal to 20, times h is equal to 20 h. Here divide by 20, even here divide by 20. Then h is equal to 3.6 meters. 3.6 meters is our answer. 3.6 meters is our final answer. We are done with this question. Now let us see shift to the next question. We shift to the last part of this question, which is question C, Roman numero 2. Velocity of the stone just before, calculate the velocity of the stone just before it strikes the ground. Velocity of the stone just before it strikes the ground. So to answer this question, this is what we are going to do. Data collection. What have we been given according to our question? Initial velocity is 0 meters per second. 0 meters per second. The final velocity is what we are looking for. Gravitational field strength is 10 meters per second squared. Okay. Okay. we continue. Now let us see. Let us plug in values we have collected. So where there is final velocity is what we are looking for. Initial velocity. Okay. So guys, let us see compress this formula first. So compressing this formula, we know that initial velocity is 0. So here we are going to write 0. And the distance we are looking for, the distance is in the vertical axis, or the distance is in the y-axis. So therefore, the distance we are talking about here is height. So this is the height. And the acceleration in the vertical axis is gravitational field strength, or acceleration due to gravity. So no wonder we have written g here. So g represents acceleration, then h represents distance. So therefore, to find final velocity, we are going to say, to find final velocity, we are going to write where there is 2, we where there is g, we write 10. Then where there is h, we write we write 3.6. We are from finding h, we are from finding the height. So the height that we found is 3.6 meters per second, 3.6 meters per second. So here we write 10, here we write 3.6, and we are going to get 72. We find the square root of this one. Let me do this. The square root of this one, we find the square root of this one. We also find the square root of this one. We are going to get 8.48 meters per second. 8.48 meters per second. Okay, we now shift to the next question, which is we are done with this question. We move to the next question, which is question B5. Question B5, figure B5.1 below is a diagram showing a wave traveling along a spring in the direction shown. Question A, in what way is this wave the same as a sound wave? In what way is this wave same as a sound wave? Okay, so both involves vibrations, stretch or compressed. Stretch or compressed spring oscillates back and forth, just like air molecules vibrate in a sound wave. Okay, so they both vibrate. Both spring and sound waves, both spring and sound waves are longitudinal waves in nature because their particles move parallel to and from the direction of the waves. So both spring and sound wave are longitudinal waves in nature because their particles propagate or move parallel to or from the direction of the waves. Both waves follow Hooke's law, elasticity. In a spring, the restoring force is proportional to the displacement or extension, just like air molecules in a sound wave experience restoring forces due to pressure changes. So these are some of the similarities. These are some of the similarities. So therefore, we are going to say both spring and sound wave are longitudinal waves in nature. Reason being, their particles propagate parallel to or from the direction of the wave. From the direction of the wave. We move to the next question, which is question B. What are the regions U and W code? What are the regions U and W code? A, Roman numeral 1, U. Okay, so to answer this question, let us look at this. So the the compressed region is called the compression. Then the stretched one is called the rarefaction. So this is the rarefaction. Then this is the compression. So U compression. Then W rarefaction. W rarefaction. We shift to the next question, which is question C. Explain why sound waves travel faster in liquids than in gases. Ladies and gentlemen, we need to remember that for sound to move from point A to point B, it needs a medium, and this medium contains solid, liquid, or gas. Okay, so in simple language, we are simply saying for sound to move, it needs particles. So in sound needs medium, solid, liquid, or gas to be transmitted, and this is what I am talking about. Why sound? Why? Sound moves. Sound waves are mechanical waves that require particles to vibrate. So in a vacuum, the empty space, there is no particle, so sound cannot travel. Sound cannot travel. So we have seen that for sound to move, it needs particles. So the reason why particles will move faster in a liquid state than in gas state is because in liquid states, particles are closely packed. So therefore, it is easier for sound to move from this particle to the next particle. So we have seen that the one that is making the sound to move fast is because of the closeness of the particles in a liquid state, the closeness of the particles. We all know that particles in gas are sparsely packed. So therefore, it is somehow difficult for sound to move. So particles are more closely packed in liquid than in a solid. We move to the next question, which is question A6. Question A6. A ray of light travels from air into water at an angle of 40 degrees between the normal and the incident ray. If this ray produces an angle of refraction of 29 degrees, calculate the refractive index of water. So the refractive index of water is fixed. The refractive index of water is fixed, and it is 1.3. It is 1.33. So for argument's sake, let us calculate. Okay, let us calculate. So this is what I'm talking about. The refractive index of air is 1. Then the refractive index of water, is 1.33. The refractive index of water is 1.33. We find the refractive index of water. So we are going to say refractive index is equal to sine incident angle divided by sine refractive angle. The refractive index, data collection, what have we been given according to our question? So according to our question, we are told that a ray of light travels from air into water at an angle of 40 degrees. So therefore, the incident angle or the incidence angle is 40 degrees. Then the refractive angle is 29 degrees. Let us plug in these values so that we can come up with a refractive index. Okay, sine 40 degrees divided by sine 29 degrees. We are going to get 1.325855723. We round off this number, we are going to get 1.33. So this is 1.33 I was talking about. It is fixed. So we have calculated this one for argument's sake. Actually, the refractive index of water is known, 1.3. We move to the next question, which is question B6, Roman numeral 2. The critical angle of water. Let us find the critical angle of water. So to find the critical angle of water, we are going to say the refractive index is equal to 1 divided by sine critical angle. The refractive index is equal to 1 divided by sine critical angle. Do we have refractive index? Yes, we have the refractive index, which is 1.33 divided by sine c. Okay, so 1.33 sine c is equal to, we do a close multiplication here. 1.33 times sine c, we are going to get 1.33 sine c. 1 times 1 is equal to 1. Here divide by 1.33, even here divide by 1.33. Sine, let us find the sine inverse of sine c. So the sine inverse of sine c, we are going to remain with the sine. Then the sine inverse of 0.751 is 48. So therefore, our answer here is 48.75. 48.75 is our answer. We move to the next question. We are done with this question. We move to the next question, which is question B7. Question B7, figure B7.1 is a diagram showing 240 volts main supply connected to a television set and 2 lamps. The question continues. The power supplied to each lamp and television is 40 watts and 120 watts respectively. When the switches are closed, A, calculate Roman numeral 1 total power supplied. They want us to calculate the total power supplied. So this question is very simple. We are just going to say 120 watts plus 40 watts plus 40. We are going to get 200 watts. So 200 watts is our answer. We are done with this question. Let us move to the next question. We move to the next question, which is Roman numerals 2. Roman numeral 2. Total number of kilowatt hours kWh of energy supplied to the circuit is 3.0 hours. The total kilowatt. Okay, so here they want us to find the energy. They want us to find the energy. So we need to remember that power is equal to energy divided by time. Power is equal to energy divided by time. Data collection. What have we been given according to our question? So according to our question, we have been given power, which is 200 watts. We have been given power, which is 200 watts. What else have we been given? We've been given time, which is 3 hours. The time that has been given is 3 hours. Remember, we also need to convert power from watts to kilowatts. Okay, so to convert this one, the only thing that we need to do here, let me do this. Can we easily convert? Okay, let me do this. So we need to remember that 1000 watts make 1 kilowatts, and we have 200 watts here. Here we are going to write x. We do a cross multiplication. 1000 times x, we are going to get x. We are going to get 1000x is equal to 200. 200. Here divide by 1000. Even here divide by 1000. The value of x, therefore, is equal to 2000. 200 divided by 1000. We are going to get 0.2 kW. So this is it. This is the power we have converted from 200. We have converted from 200 watts to 0.2 watts. Time has been given, which is 3 hours. Now let us plug in these values. Where there is power, we are going to write 0.2. Where there is energy is what we are looking for. Where there is time, we have written 3. We do a cross multiplication, we are going to get 0.6 kilowatt hour. So we have successfully managed to find the energy. So these are suggested units according to our question. So as we can see, we have not calculated our energy in joules. We have calculated our energy in kilowatt hour, in kilowatt hours. We are done with this question. Let us move to the next question. Calculate potential difference across the television set. Calculate potential difference across the television set. So we need to remember something here. In a parallel circuit, the voltage across each branch is the same. This is because all components are directly connected to the same 2 points of the power source. So therefore, the voltage is the same. So the same voltage which is here, which is 240, is the same. Since these are connected in parallel, so the voltage is the same. We are done with this question. Let us move to the next question. We move to the next question, which is question B8. Question B8, figure B8.1 is a diagram showing a coil of wire wound on a soft iron core with the current flowing in the direction indicated by the arrows. B8A, mark N and S poles. Mark north and south poles induced on the iron core. Okay, so they want us to mark N and S and S pole. So we are going to use right hand rule for electromagnets. Curl your right hand fingers along the coil's current. Your thumb points to the north. So the thumb will point to the north. Then we can also use compass test. The compass needle points away from the North Pole and towards the South Pole. So the compass, where the compass will point, that is the South Pole. Where the compass will point, that is the South Pole. So the compass will point away from the North Pole and it will point towards the South Pole. We can also use magnet test. A non-North Pole repels a iron core's North Pole. So if we want, peradventure we want to know if this pole is a North Pole, we can bring the non-pole. We can bring the non-North Pole. We bring the non-North Pole. So if we bring it near to the North Pole, it will repel. Then we will know that this is a North Pole. If it get attracted to that pole, then we will know that this is a South Pole. So we can also use this test. Okay, we can also use this test. So these are some of the 3 tests that we can apply. These are some of the 3 tests that we can apply. So here we are going to apply right hand thumb rule. So where this thumb is pointing, let me play this one again so that you see. So where this thumb is pointing, so this is the North Pole. So you need to curl your fingers like this. So where this thumb is pointing is the North Pole. Okay, is the North Pole. Okay, so therefore this is, if we curl our fingers like the way fingers are curled in the previous slide, this one will be our North Pole and this one will be our South Pole. Okay, we are done with this question. We move to question B. We move to Karibu.